So I'm just going to spin Alina very slowly, and you're just going to observe the eye movements and the speed and direction of the eye movements. Okay?
Science.
Right, so just look ahead as you normally would.
What? We're creatures.
Alright, so what did you see?
Looking from the direction of movement. That show?
Yeah.
So it's looking toward the direction of
And
movement.
what was the speed of those eye movements?
Slow.
I think it was really fast.
Medium.
Yeah. Medium.
Okay. So which direction were the most obvious eye movements in? To her right?
Yeah.
Her right?
Yeah.
Yeah. Yeah, so you might have seen if she was focusing on something in her visual field, then you might have seen moving slowly to her left. And then as soon as some point that she's focusing on leaves her visual field, then you might have seen the fast eye movements in to her right in the direction she was spinning. So those fast eye movements are that reflexive response to the vestibulo-ocular reflex. Okay. And then the next thing we're going to do is, Alina, I'm going to have you close your eyes and also tilt your head forward. So tilting the head forward to get this semicircular canal horizontal.
The same direction.
And then I'm going to spin her, and then she's going to tell which way she perceives she's spinning. So Alina, if you think you're spinning to the right, you move your thumbs to the right. If you think you're stopped or not spinning, keep them up. And then if you think you're going to the left, put them to the left. Okay? And then we need a couple people to time the duration of each direction that you think she's spinning. Okay, so we got people ready to time.
So how long it takes her to say which direction she thinks she's spinning?
Okay. Alright, so close your eyes. You ready? Alright. You can open your eyes now.
Just a second.
So what do we see in this case?
She thought she stopped in the middle.
Mm-hmm. Yeah, I saw it. Yeah.
And then when she stopped, she thought she was going still.
Yeah.
So
Look at
she
the light.
thought she was stopped during the middle of the spin, and then when she was stopping, she thought she was going to the left, even though she was stopped. Does anyone have an explanation for what we saw? Mm-hmm. Yeah, so when she first starts spinning, her head is spinning. So this is rotating. In her left ear, this is rotating. and then the fluid is viscous and has inertia, so it's not moving at first. So when the head's rotating, these hair cells are being pushed against the fluid, so they're getting bent. But then during the middle of the spin, at a constant velocity, this fluid has caught up with the rotation of the head, and so it's moving at the same speed at which the head is rotating. So the hair cell is not getting bent there. And then what's happening when she's slowing down?
The loop is still moving in that direction, so even if she stops, it still perceives motion.
Which direction is the end of it?
She's going the same direction as the spin.
Yeah, and then so the endo lymph is still rotating. So then which way does the hair cells get bent?
The direction is there.
Would it be the opposite?
Yeah, well, the opposite of what we saw in the first
Mhm.
case. So if this is the left ear, I'm not actually sure which way you're getting bent, but yeah, it should be the opposite of the first case. So then she thought that she was spinning in the opposite direction. And then, alright, so the next case, Alina, you're going to close your eyes again and tilt your head forward again. And this time, I'm going to spin her really fast and then abruptly stop her. And when I do that, she's going to lift her head or open her eyes, and you're going to observe her eye movements. All right, you ready? All right, so what do we see here?
I didn't notice it.
Her eyes were shaking.
Oh, was it?
Or was going back and forth?
Mm-hmm.
Yeah.
But she was like so focused on something, her head bob shaking.
Yeah.
Yeah.
Yeah. Could you tell in which direction the fast eye movements were?
It's the
I
same
don't-
way. Yeah,
I-
that makes sense, right?
Which way?
The same way as the
Yeah, I was going like this, but you can't really tell.
Yeah.
Yeah, it's hard to tell, right?
Mm-hmm.
Yeah. So in the first case when I was spinning her, slowly you saw fast eye movements to the right.
Mm-hmm.
But when I abruptly stopped her, the endolymph and the semicircular canals are moving faster than the head because the head is stopped now. So which direction would the fast eye movements be? It's in the direction that she thinks she's rotating, right?
Mm.
To her left.
Mm.
Yeah. Because that would be the reflexive response to rotating to the left.
But she's really rotating to the right.
Mm.
But then the slow eye movement, is there even slow eye movement?
That was in the first case that you did, right? The slow eye movement, when it was just like the slow, like her looking.
Yeah, so in this case, when I abruptly stopped her, it's all kind of fast and it might be hard to tell. But the slow eye movements would have been to try and stabilize the visual field.
Mm-hmm.
So those would have been opposite the reflexive response. So the reflexive response was fast to her left. So then the slow would have been to try and bring the eyes back to keep a stable vision.
But we didn't really see that? Or was that what we were talking about?
The very first time, that's what we were talking about. The slow, like trying to stabilize your vision.
I'm confused about the
Yeah.
data on here.
Maybe if you slow down the video, you might be able to see the difference in the settings. But yeah. So in the next case, well this we're going to try and override that response. Because this is a polysynaptic reflex. So what does polysynaptic mean? Yeah, so whenever there are multiple synapses, there are opportunities to override that response or have the response change. So in this case, we have things like, well, what's in her vision? So if she was able to focus on one thing, then she might be able to override that response. So that's what we're gonna try in this case. So I need someone to stand in front of her, and then when I abruptly stop her, you're gonna hold out your, well, you're going to observe the eye movements at first, and then hold out your thumb, and Alina is going to focus her vision on your thumb to try and override that response. So you're also going to try to time the duration of the fast eye movements too. Okay? Are you ready? Close your eyes. And then hold out your thumb. So was she able to override the response?
Was fast.
Yeah.
Yeah. So the duration of the fast eye movements was a lot less than before. Yeah. So that's the cool thing about the polysynaptic reflex is that it can be overridden by other things, like what's in your visual field. So like figure skaters or gymnastics wouldn't want to have that reflexive response, like when they stop spinning. So they might use something in their vision to override that response. Okay. So now we're going to do the same thing, but I'm going to spin her slower. So now we're going to time the duration of the response when I spin her slower. All right, you ready?
Mm-hmm.
So did you see the response? How did that compare to the last two times? Longer? So how did they compare to the first time that I spun her really fast?
It actually took almost the same time as from what I'm seeing. Which I'm kind of confused about. 13 to 4.
It might be me
Because you focused on something.
Yeah,
I was
focusing.
focusing.
I was
But
trying
isn't that
not
what
to,
you do
but it's
normally
hard.
no matter what? Is focus on something to stabilize yourself. So whether that's your thumb or
extending
something
your
from
vision.
far away, it's
Yeah.
going to be the same.
That's true.
What do you know about reflexes? What does the response depend on?
Stimulus?
Yeah.
The frequency.
The intensity of the response depends on the intensity of the stimulus. So if we have a lower stimulus, we would expect a lower response, right? So yeah, well there are other factors here, like what you could be focusing on. So that might be why we didn't see such a difference in the duration of the response.
So the first one I saw 8 seconds, the second one, this one is 7 seconds. So is that like a bit that difference that you're talking about because it was slower, it took her less time to stabilize? Is that what you're talking about?
Yeah, we'd expect it to be faster. The difference between 7 and 8 seconds is pretty small. I would have expected a bigger difference. But we can try it again if you're okay with that.
Yeah.
Okay. So what was the time on that one?
I think you stopped it way too late. It was like another like 3 or 4 seconds before that.
Okay.
Yeah. It's like 11 or 12 seconds.
Okay.
Yeah, another factor is the speed is hard to control,
Mhm.
because that's just what I think the speed that I'm spinning her at. But we would expect a shorter duration for a lower stimulus.
Mhm.
There, it was going like.
Yeah.
Yeah.
And plus her
Yeah.
head was like moving too.
So why might the eyes be going up and to the left and not just to the left?
Because you integrated another
The
set
axis.
Yeah.
Axis.
Um,
Yeah.
Yeah. So when we tilted the head, stimulating the vertical one as
Mhm.
well. So this is the one like if you're doing backflips or something. So the eye movements would be up and down. So when you're stimulating both the horizontal and the vertical, then we're seeing eye movements both to the left and up. So looks diagonal. Alright, so that's
spinning
all
right.